Okay, we're going to have some more examples of dative covalent bonds now, and this is something I mentioned in an earlier video. I wanted to talk about nitric acid, and I couldn't really, HNO3, because nitric acid contains a dative covalent bond in it. So that's why you wouldn't have come across the structure of nitric acid at GCSE. Okay, so what does it look like? Well, if you have nitrogen here, it forms a double bond to one oxygen, another oxygen. So those oxygens are both happy because they're forming two bonds. Nitrogen looks like it's reasonably happy because it's forming three bonds, and that's what it likes doing. But nitrogen's also got a lone pair there, and that lone pair can form a dative bond to another oxygen. Okay, so that is the structure of nitric acid, HNO3. So let's draw a dot cross diagram for that. So here's my nitrogen in the middle. And I'll draw the hydrogens in red. Hydrogen in red, sorry. Right, now this is the, so here is, we put here, so there's a double bond, so we want a dot and a cross and a dot and a cross. This is oxygen. Let's think, so the oxygen will have, it's got 2 electrons in this bond, so it's got 4 others, so it's got 2 lone pairs. So I'll draw those, yeah. So that oxygen's okay. This oxygen here, there's a single bond there, so we want a dot and a cross, and here a dot and a cross from the hydrogen. I've drawn, so it should be a cross really. 1 minute, I'll dot that red one. Okay, so I've drawn 2 crosses for this oxygen, so there are 4 others, so there's 2 lone pairs on this one as well. Here's our nitrogen. Okay, let's think about the nitrogen. Now I have only drawn 3 of the nitrogen's electrons, 3 dots, so there's got to be 2 more, and they are here in this bond here. This is the dative bond, right? And this one is oxygen. Now both of those electrons come from the nitrogen, neither of them come from that oxygen. So the oxygen's got 6 electrons in its outer, 6 of its own electrons out of shell, so that's got 3 lone pairs. So that's going to be like that. And if you look at every molecule, every atom there has got a full outer shell, so they'd be all, that structure is reasonable. That's the structure of nitric acid. That's why I couldn't talk about it a few lessons ago. And of course, if you want to think about the structure of the nitrate ion, NO3 minus, all you've got to do is you've got to lose this hydrogen here is going to go. That's gone, but it comes off as H plus and it leaves its red electron behind, giving this is the nitrate ion, and the whole thing is going to be negatively charged because of that extra electron. Okay, and again the negative charge is not just sitting on that oxygen there, it's actually spread out the whole molecule, the whole ion, sorry. Yeah. Let's look at another nitrogen containing compound which has got a dated bond in it, and that is N2O. Okay, N2O, nitrous oxide. Okay, that has got a dated bond in it. What you have is you have 2 nitrogens, just kind of norm, yeah, and that's like an N2 molecule with a triple bond, but the nitrogens have got lone pairs. So this one actually, the lone pair on this nitrogen forms a dated bond to an oxygen, and you form N2O. So if you draw a dot cross diagram for that, so you want a triple bond in the middle here. This nitrogen has got a lone, it's got 3 electrons there, so it's got 5 altogether, so it's got a lone pair there. This one has got a lone pair here, and this one forms a dated bond. I draw the oxygen, I'll draw that in red. And the oxygen has got 6 of its own electrons in the outer shell, so that's 3 lone pairs on the oxygen. So that is the structure of N2O nitrous oxide. As I say, nitrogen forms quite a lot of compounds with dative bonds in them. Another one which you'll come across, and you've probably heard of, is ozone. And you may know that the formula for ozone is oxygen, but it's not O2, it's O3. Okay, so we see how that works. You have just a normal O2 molecule, and of course each of those oxygens has got 2 lone pairs on it. One of the lone pairs forms a dated bond to another oxygen. So if we draw the dot cross diagram for that, we've got a double bond here, dot cross, 2 lone pairs on this oxygen, one there, one there. 2 lone pairs on this oxygen, and this one forms a dative to a third oxygen, which I'll do in red, and that's just like the one at the top there. That's got 6 of its own electrons, so 3 lone pairs. So that's another molecule which has got a dative bond in it. Okay,